Hello and welcome everybody to this video on position, velocity, and acceleration. So on the screen here, yeah, pretty sure it's working. I hope it's working. On the screen here, um, there is a position function. So it's denoted S of t. Sometimes you'll see P for position. Sometimes you'll see S for position. Sometimes you'll see R for position. It's all about reading the problem. It's all about context, everybody. Okay. Now, um, here is the basic idea. The basic idea, of course, is if I move something from one place to another. Okay. So in other words, if this dot moves from here to here, then its position changed. Okay. Now, um, in calculus, we're dealing with continuous functions, things like that. So for that reason, teleportation is not allowed. In other words, if I want to move this dot from here to here, then it's going to take me a little bit of time because it has to cover this distance. Okay, and the amount of time it takes is going to determine how fast the dot moved from here to here. Okay, um, so in other words, like I said, this thing takes some time. It takes some time to cover the distance. Okay. And then also this requires my position to change. Again, and again, I've already put that here. Position changed. Okay. So in other words, if I take the tiny little bit of distance, in other words, if I just move this thing from here to here, and I have the tiny increment of distance, and then divide that by the tiny increment of time, what I've done is I've moved this thing a little tiny bit, and it took me a little bit of time to do that. So think about distance per time. Distance per time. What is that? Something like miles per hour, something like kilometers per hour, something like meters per second. It is a velocity. If I can spell, give me 1 second. Fix that. This is velocity. Okay. Um, so, if we're talking about one-dimensional motion, let me my keyboard here. If we're talking about one-dimensional motion, we can consider this to be like an axis. We can say this is like the x-axis. So we can say that this particle is moving along the x-axis. Okay. And so if that's the case, if a particle is moving along the x-axis, then the s just becomes the whatever the x value is. It's the change in the x value with respect to time. How fast is this thing sliding along the x-axis? Okay. Now velocity is literally two things. It's speed plus direction. Okay. And if we were working with two-dimensional problems, there would be a huge distinction between velocity and speed. Um, in one dimension, your directions are very limited. Okay, so in one dimension, your direction is limited to positive or negative. Okay, so in other words, I can travel along the axis this way, or I can travel along the axis in the other way, and that would be negative. Okay, so those are our choices for the direction of velocity, either positive or negative. We're talking about one dimension. Um, awesome. Okay, so now let me think. Let me think. Yeah, I guess the last thing I want to say about velocity is, it's like if it takes less time to get from here to here, then that's a faster velocity. And if it takes more time to get from here to here, then that means we're going slower. Okay, so in other words, if dt is smaller, then we're talking about something that's moving faster. If dt is bigger, we're talking about something that's moving slower. So let's keep that in mind. Okay. All right. Now, let's get some other stuff out of the way that's really important. This one here, speed. Speed is the absolute value of velocity. Okay? And again, velocity is, if we're talking about one dimension, we're talking about dx dt. So you take the derivative, and then you just take its absolute value, make it positive. And that gives you the speed. Okay? So speed has a meaning. It tells us how fast. How fast are we moving? That's what speed's all about. How fast are we moving? Velocity is how fast are we moving and in what direction are we moving. Speed is just how fast. Okay? All right. Next is acceleration. Okay? Now, in order to understand this, the difference between acceleration and velocity, let's consider a couple things. First, think about dropping something. When you drop something, when you first let go, the moment you let go, the thing's not moving. And then as the object leaves your hand, the speed increases and it goes down. Okay, so speed increasing and going down. Okay, so again, imagine something falling. All right, now the rate at which the speed is increasing, that is the magnitude of the acceleration, and the direction that the speed is increasing when you drop something, that is the direction of the acceleration. Okay, so in other words, acceleration is literally just the derivative of velocity. Okay, so you take your velocity function, you take its derivative, the change in speed, or I'm sorry, the change in velocity is your acceleration. Okay? All right, so now, to kind of put this together a little bit, let's say we have an object, and let's say that we throw this object straight up in the air. Okay? It goes straight up, and then it comes straight down. Okay? On its way up, okay, let's think about what gravity's doing. Okay, I'm gonna do green for gravity. Okay? The whole time, gravity, which is an acceleration, by the way, okay? Acceleration due to gravity, okay? And if you want a number for it, it's negative 9.81, okay? Meters per second squared. So gravity is pushing this thing down the whole time, okay? So the direction of acceleration is down, okay? Now, when this thing is on its way up, gravity is still acting on it, okay? So when it's on its way up, so upward. When it's upward, the velocity is positive. The acceleration is negative, okay? So in other words, velocity and acceleration are in opposite directions, okay? V and A, opposite directions. Okay? On the other hand, okay, when we're going downward, the velocity is negative, the acceleration is negative as well. Okay? So the gravity is helping the thing that's already going down to move down even faster. Okay? So in this case, velocity and acceleration are in the same direction. And this has implications on the speed. Okay? So again, imagine you're throwing this thing up, and as soon as you throw it up, it starts to slow down. Okay? So in other words, speed decreases. Or speed decreased, whatever. And then on over here, okay? When the thing's already going down and gravity is helping it go down even more, we're talking about the speed is actually going to increase. The thing's going to go faster. Okay. So the way to look at this is, what does it mean for speed to increase? Well, it means that I need to be traveling in a direction. I need to be traveling in the same direction I'm being pushed, right? So gravity's pushing me down. As long as I'm traveling down, my speed's going to increase because I'm being pushed down. On the other hand, if I'm trying to go up and I'm being pushed down, my speed's going to decrease. Okay. So there we go. There we go. So what's the big ideas here? Big ideas. Velocity is the derivative of position. Acceleration is the derivative of velocity. Okay. Now, let us use our example here. Here we go. Here's our position function. And what I want to do is, I guess I'm going to write it over here. Let me write it over here. So, I'll write it down again. T cubed over 3 minus 2t or plus 2t minus 2t squared. Don't want to screw it up. Plus 3t plus 5. There we go. All right. Here's my position at any time t. And we have several questions to figure out. One, what's the velocity function? Second, what's the velocity at 2 seconds? Next, what's the acceleration function? What is the acceleration at 2 seconds? Okay. Let's see. We might come up with other questions later. But then we also have, when is the speed increasing? When is the speed decreasing? And we can also ask stuff like this. When is the thing stationary? All right. Very common questions here. This is very typical type of stuff. Okay. All right. So first we have a position function, and we're being asked to find the velocity function. So, what do we just learn? The velocity is the derivative of the position. Okay. So I'm just going to take the derivative of this straight away. So this is going to be 3t squared over 3 minus, bring the exponent down, 2 times 2 is 4t plus 3, and then the derivative of 5 is 0. Okay, so there's v at t. So first question done. Okay. Velocity at 2 seconds. We're just going to plug in 2 and be done. 3 divided by 3 is 1. So 2 squared is going to be 4 minus 16 plus 3. All right. That's going to be negative 12 plus 3. That's going to be negative 9. All right. And let's say this is meters, and let's say that t is seconds. Okay, so that means this is going to be meters per second. All right. Good. Okay, now let's find our acceleration function, which, is going to be 2t minus 4. Plug in 2. 2 times 2 is 4. 4 minus 4 is going to be exactly 0. Check that out. All right. A of t, A of 2. All right, so done, done, done. Okay, now, speed increasing, speed decreasing. Okay, This one's a little tougher, right? So speed increasing is when velocity and acceleration are in the same direction. Okay, So we got to figure out where velocity is positive or negative. So okay, let's stay with me here. We need to know. We need to know when velocity is positive, velocity is negative, and we also need to know when acceleration is positive and acceleration is negative. Because if velocity and acceleration are the same sign, we're speeding up. If velocity and acceleration are opposing signs, then we are slowing down. Okay, so let's take our velocity and let's set that bad boy equal to 0. Okay, so here's our velocity function. Again, 3 over 3 goes away. We're going to have t squared minus 4t plus 3. We're going to set that equal to 0. We're going to think about two numbers and multiply to positive 3 and add to negative 4. Negative 3 minus 1, right? T minus 3, t minus 1 equals 0. And we get t equals 1, or t equals 3. Okay? So in most of these problems, unless otherwise specified, they'll tell you that t has to be positive. Okay? We're going to go ahead and keep with that convention in this problem. So let's keep that in mind. So in other words, here we got our solutions. We're not going to go to negative infinity to infinity. We're going to go 0 to infinity because t has to be bigger than or equal to 0. All right, so here we go. Let me change my color here. We're going to make intervals. So it's going to be 0 to our first solution. Our first solution to our second solution. And our second solution to infinity. All right. Okay, so now 1/2. 1/2 is in here. 2 is in here. And 4 is in here. Okay, these are the numbers I'm going to pick to plug in to my velocity right here. Okay. So 1/2. 1/2 minus 3, that's definitely negative. 1/2 minus 1, that's definitely negative. Negative times a negative, definitely a positive. Okay, so our velocity is positive there. If I plug in 2, 2 minus 3 is going to be a negative. 2 minus 1 is going to be positive. That's definitely going to give me a negative overall. And finally, if I plug in 4, 4 minus 3, positive. 4 minus 1, positive. That's a positive. There we go. So now we know where our velocities are positive and negative. Now we just got to do the acceleration, which is no big deal. Acceleration, take another derivative. 2t minus 4, set that bad boy equal to 0. Add 4 divided by 2, t equals 2. So we are talking about, ladies and gentlemen, we're talking about 0 to 2. We're talking about 2 to infinity. All right. I'm going to choose 1. I'm going to choose 3. I'm going to plug it into my acceleration. 2 minus 4, negative. 6 minus 4, positive. Okay, all right. So now, when is okay? So, sorry, we got a lot to look at now. Okay, so we got 0, 1, 0, 2. Okay, 0, 1 is the smallest of those. So 1, 0, 1. My velocity is positive. My acceleration is negative. Okay. So we're going to note that. Velocity is positive. Acceleration is negative. So therefore, I am slowing down. Okay. Justification. Don't forget your justifications, people. All right. Okay, so now after 1, 1 to 2, right? 1 to 2. So 1 to 2, velocity is negative. Acceleration is negative. So we are speeding up. And we're going to keep on going. After 2, what do we hit next? We hit 3. 2 to 3. So what's happening? 2 to 3. Velocity is negative. And 2 to 3, acceleration is positive. And so those are opposite signs. So we are slowing down, ladies and gentlemen. Slowing down. Right. And is that okay? What about 2 to infinity? Ooh, okay. Or I'm sorry, no, 3 to infinity. 3 to infinity. So on 3 to infinity, what do we got? We got positive acceleration. We got positive velocity. So we got velocity positive, acceleration positive. We are speeding up. All right, there we go. Boom, boom, boom. Okay, so there we go. So what are the big ideas here? Big ideas, first of all, is velocity is the derivative of position. The direction in one dimension is either positive or negative. Acceleration is the derivative of velocity. Speed is the absolute value of velocity. Speed tells you how fast you're going. Speed is increasing if velocity and acceleration are in the same direction. Speed is decreasing if the velocity and acceleration are in opposite directions. All right, and we got an example here, full example. We have some easy stuff and a little bit of harder stuff, but there we go. I'm gonna call this video. See you later.